Good morning to everyone. I'm Sangeeta Lakshmi, working as assistant professor in R.M.K College of Engineering and Technology. Today we are going to see the session 5 of Unit 2 MOSFET amplifier. What are all the topics we are going to discuss in this? Small signal analysis of common source amplifier with bypassed RS. This is the topic we are going to discuss today. You have to know what is mean by small signal analysis first of all, right? So small signal analysis is nothing but the AC analysis. Why it is called as small signal analysis means, see here, this is your DC signal, right? This is your small signal, that is AC signal. It may be your audio signal or it is video signal, right? So this is called small signal. Why it is called small signal means, when compared to DC source, always the DC source is on order of 10 volts or 15 volts, like that we have. Okay, but whereas in the input signal, that is audio as well as the video signal, in the order of millivolts, for example 50 millivolts, like that we have. So when compared to DC signal, this AC signal is very less. That's why the analysis only with respect to AC is called small signal analysis, right? In the previous session, we have seen the DC analysis only with respect to this VDD. We have analyzed how to draw the DC load line, where we have to fix a Q point, everything we have analyzed in terms of what? DC analysis. Okay, so DC analysis is called as large signal analysis, whereas AC analysis is also called as small signal analysis, right? This is a difference. Okay, and this is common source MOSFET. Common source means always you have to think the input we have to give at gate terminal, right? The output we have to taken at the drain terminal, means the common terminal is source. Okay, that's why it is called common source MOSFET amplifier, right? See here, this is your input signal Vi. It is given at the gate terminal, right? This is your gate terminal. So this is your MOSFET transistor, right? So here it is NMOS. So we have to put the direction like this. It is gate. This is a drain terminal and it is source terminal. Okay. So the input is given at the gate. The output is taken at the drain. That's why it is called common source MOSFET amplifier. Okay. So what is meant by bypassed RS? See here, across RS we have source capacitor, or it is called as bypass capacitor. What is the role of this bypass capacitor? Means generally the capacitor will allow, these all the capacitor will allow only the AC signal, it will block the DC signal. Okay, so why we have to connect this source capacitor across this RS means, first of all we have to know all the elements in the amplifier. Okay, so in this R1 as well as R2 both are called as biasing resistor. Okay, whereas this RS provides the good stabilization, that is always we have to keep the Q point in a stable position in order to get the faithful amplification. So that role is done by this source resistor. Okay, so if you are using the source resistor, this will maintain the Q point in a stable position. That is the advantage of using RS. But the disadvantage of RS is, if you are using this, this will provide some negative feedback. Okay, so if it is negative feedback, it provides, what happened, the gain will be reduces. Because of this negative feedback, the gain will be reduces. So we need, that is we have to keep the Q point in a stable position. In addition to that, we have to maintain the gain also in the same value, right? We have to maintain the same gain. So what we have to do is, we have to connect this coupling capacitor across this RS in order to compensate the reduction of gain due to this RS. Okay, so coupling capacitor is here used to compensate the reduction of gain due to RS. Clear everybody? Okay. Then what is the role of this coupling capacitor 1 and coupling capacitor 2? These two are isolating your input signal from the from the DC supply, right? So the DC as well as AC should not mix together. So the coupling capacitor role is to isolate both the signals so that this input signal will not alter the Q point. Okay, so you have to know each and every element present in the amplifier, right? This is RSI is nothing but the source resistance of the input signal. This is not the external resistance. This is the resistance exhibits due to the source. Okay. So R1, R2 is again I am telling R1, R2 is the biasing resistor and RS is provides the that is to maintain the Q point in a stable position we need RS, but it provides a negative feedback. Due to that the gain will be reduces. So in order to compensate the reduction of gain due to RS, we have to use bypass capacitor across this RS, right? Okay. So after knowing each and every component operations, we have to go for the small signal analysis. So for small signal analysis, we have to follow some steps. What are the steps we have to follow is, first we have to make all the DC source to 0. So wherever you have the DC voltage, that we have to set to 0. Second step is, this is small signal analysis. So we have to all the capacitor we have to short circuit. Why means, you know this reactance of the coupling capacitor XC1, which is equivalent to 1 by 2 pi FC1, right? This is the small signal, that is nothing but the AC signal. So for AC signal, you know that the frequency is not 0, right? So if the frequency is increases, definitely the reactance will be reduces, right? Ideally, we can say the XC1 is, ideally it is, we can say 0. So if it is 0 ohms means what is the meaning? It is open circuit, sorry, short circuit. Okay. Always you can remember, if the resistance is 0, that means the capacitor will produce a short circuit, right? If the XC1 is infinite means it exhibits open circuit. So you have to remember this. So for small signal analysis, first step is we have to make all the DC voltage to 0. Second step is we have to short circuit all the coupling capacitor. Then we have to draw the equivalent diagram for this MOSFET. In the previous session, I told you what is the equivalent of this MOSFET. So we have to use a hybrid pi model for this equivalent MOSFET diagram. Okay. So we have to replace this. So how to draw this is, see here, I will draw here. First of all, we have to draw the equivalent diagram for this transistor. So for the transistor, you know that gate is input, output is drain, and common terminal is source. So in between gate and source, it is NMOS, no? So in between gate and source, we have VGS. In between drain and source, we have the current source, which is nothing but the GM into VGS, right? This is your equivalent diagram for the MOSFET. Here we have one R0 resistance. Clear? See, from the gate terminal, you can start from this gate terminal. You have the this coupling capacitor we have short circuited, right? We have short circuited all the coupling capacitors as well as bypass capacitor for the small signal analysis. And then this VDD, that is DC supply, we have to make it to 0. So 0 means ground, right? So if you are short circuiting this that is bypass capacitor, the current from the source all will be going through this side. None of the current will be going through the RS resistor. Thereby this RS will be bypassed from the circuit. That means the RS role is ineffective from the circuit. Okay, so the source is directly connected to the ground because of short circuit of this bypass capacitor. That's why the name is given that it is bypassed RS. Common source MOSFET amplifier with bypassed RS. Okay, this part is over. The source is directly connected to where? Ground. So here I have to connect the source is directly connected to ground. Then from the gate I have this R1 resistor, then R2 resistor. So from the gate I have to connect two resistor, right? R1 parallel to R2. See here, this R1, one end is connected to gate, another end is connected to R2. Similarly, this R1, another end is connected to where? It is ground terminal, and R2 also connected to ground terminal. So, this R1 and R2 is look like parallel. Okay, parallel combination in between gate and ground. So, source is already connected to ground, so I can connect this to ground. And similarly, from the gate, we have another resistance RSI. So here I have to connect one RSI resistance because the coupling capacitor short circuited. Here we have the input voltage VI. It is connected to again ground, right? So I have to connect this, all are ground. So gate side is over, source side is also over. Then from the drain part, you have RD resistance. Okay, so here you have RD resistance. So from the drain we have RD resistance, another one is RL resistance. So from the drain I have to connect two resistor, one is RD and another one is RL, right? So RL another end is connected to again ground. Similarly RD another end is connected to ground. So this is ground now, so I will connect all this thing. So this is the way we have to draw the equivalent or small signal equivalent for the common source MOSFET amplifier. Okay, so I hope everyone understand how to draw this equivalent diagram, right? So this is the diagram we are getting. I told you how to draw this, right? The same diagram, whatever the diagram we have drawn here, the same diagram here we are getting. So in this you have to know when we are looking from here, this is your input resistance. That is input resistance looking into the amplifier, right? So when you are looking from here, this is your output resistance, right? So our aim is to calculate three parameters. That is, we are going to analyze a common source MOSFET amplifier. So how we can analyze means to calculating three parameters. That is, first parameter is input resistance, second one is output resistance, and third one is voltage gain, right? So by deriving these three parameters, we can analyze how much this common source MOSFET amplifier is suitable for particular applications. Okay, so whether the input resistance is high or low or medium, whether the R naught is high or low, or how it is produces the voltage gain, whether it is high or less, like that we are going to analyze. This is our objective. Okay. So for the analysis, first we are going to calculate what is the input resistance Ri. So what is input resistance means? This is the resistance looking into the amplifier. Okay. So if you are looking into the amplifier, what is the diagram you are getting here is, you have to know the equivalent diagram for the, first of all you have to know the equivalent diagram. I told you when you are looking from here, you are having input resistance Ri. So when I am looking from here, see here, I am having what? The R1 parallel to R2, right? So when I am looking from here, I am seeing that I am having the resistance of R1 parallel to R2. So input resistance is simply R1 parallel to R2. Then we are going to calculate what is output resistance R0. So output resistance is looking back to the amplifier. Actually, you are looking back to the amplifier this side, what is R0? Okay, so when I'm looking from here, I have to find out the R0 resistance. For that, the condition is to find R0, you have to make, that is R0 equal to Vx by Rx, sorry, Ix, at the condition of Vi equal to 0. What is meant by Vx by Ix? See, for example, I will tell you, suppose somebody is giving one resistance to you. Okay, so the resistance is R0. You have to find out what is the value of this R0. The color code is missing in this resistor. So if the color code is not there, means we could not able to find out the resistance value by seeing them, right? So instead of that, another method to calculate the resistance is we have to apply the known voltage. That is, you know the voltage. What is the voltage you are applying here? For example, 5 volts if you are applying here means due to that some current is flowing here, right? That current can be measured by the ammeter. Okay, so the current flowing through the ammeter is, we can measure that Ix. So how to find out R0, which is equal to known voltage Vx by the current flowing through the resistor is shown by the ammeter, which is Ix, so that we can easily find out what is R0. This is the way to find out any resistance. Okay, here also the same thing. So if you want to find out the output resistance at the amplifier output side, we have to apply known voltage Vx by Ix at the condition of input voltage. This is Vi equal to 0. That means this input voltage should not affect the resistance at the output side. So to make or to make ineffective of this input source, we have to make this Vi equal to 0. Okay, if I'm making Vi equal to 0, definitely what happened? The voltage across R1 parallel to R2 is nothing but the VGS, right? The voltage across R1 parallel to R2 is nothing but the VGS. So if I'm making Vi 0, definitely VGS also 0, right? If VGS 0, Gm into VGS, that is also 0. Gm into VGS is nothing but the current source, right? Current is 0 in the sense it is open circuited. This is open circuited. Current 0 means it is open circuited. So if it is open circuited means from the output side, it's look like this. I will draw here. The current source is open circuited. Here I am having the resistance R0. Here I am having the resistance RD and another resistance is RL. Right? So when I'm looking back to the amplifier, this is the amplifier back. What is the resistance I'm seeing? These three resistors are connected in parallel. So output resistance equal to what? Output resistance equal to R0 parallel to RD parallel to RL. Okay. So how to calculate the R0? You have the formula R0 equal to, what is the formula to calculate means? We have seen in the previous session, R0 equal to, I will write here, R0 equal to 1 by lambda into ID. Okay, this is the formula for calculating R0. This lambda is nothing but the channel length parameter. This ID is nothing but the drain current, right? Okay. Then we are going to find out what is AV, voltage gain. Okay. So to find out the voltage gain, we have to use a formula, that is voltage gain is the ratio between output voltage by input voltage. Okay. So first of all, we have to find out what is V0, right? So we have to find out what is V0. So for that, see here, the V0 is the voltage across here, right? So just you can combine these three resistance into single resistance, that is R0 parallel to RD parallel to RL, right? So instead of these three resistance, you can use single resistance, which is nothing but the R naught parallel to RD parallel to RL. I will draw it here so that you can understand clearly. Here, this output side I am drawing here. Here I am having the GM into VGS, right? Here I am having only one resistance, which is R naught parallel to RD parallel to RL. Okay, so the current flowing through this three equivalent resistances I naught. What is the voltage across the resistances? It's nothing but the V naught. Okay, so now you tell me what is the voltage across this whole resistance means. This current into this resistance is nothing but the V naught, right? So V naught equal to what? I naught into R naught. This R naught is nothing but the output resistance, which is nothing but the what? Small R naught parallel to RD. This is nothing but the capital RR, that is output resistance of the amplifier is nothing but the R naught parallel to RD parallel to RL. So I have to write, instead of this R naught, I have to write R naught parallel to RD parallel to RL. Right. What is I naught here? This I naught is the current flowing through this resistance. And GM into VG is also current source. But this current is going in this direction. Right. But this GM into VGS is going in the opposite direction. So what is the relationship between I naught and GM into VGS? I naught equal to minus GM into VGS, right? So next I have to find out what is VGS, because my aim is to find out AV. But here in this formula, V naught equal to minus GM into VGS. This V naught is in terms of VGS only we have here. I have to replace this voltage in terms of VI so that I can calculate AV. So how to let us replace this VGS means VGS is the voltage between gate as well as source, right? Gate and source. This is the same voltage. It is applicable across this R1 parallel to R2 also. So we can take it, the voltage across this R1 parallel to R2 is Vin. Thereby Vin also equal to VGS, because parallelly all the voltages are equal. So Vin equal to VGS. Okay. So now you have to substitute this VGS equal to Vin in this first equation. You will get what? Instead of VGS, I have to substitute Vin. Okay. Again, I need only VI, not Vin. So how to find out this Vin is, you have to just use this circuit. How the circuit is came here is, in the input side you can see, if I'm looking from here, this is my input resistance looking into the amplifier. So what is the resistance here? I'm looking from here means the resistance is Ra, input resistance Ra. So just you can compress the whole circuit. For example, if you have like this, if you have like this, you just compress the whole by this side. Here you have already resistance. Here it is current voltage source. Okay. So if I compress all the circuit together, when I'm looking from here, I'm having the resistance of Ra. So I'm drawing the same diagram RSI, this input voltage, right? When I'm looking from here, I'm having the resistance of Ra here. So that's why the circuit came like this. So in this, Ri equal to what? You know that R1 parallel to R2. The voltage across R1 parallel to R2 is, it's nothing but the VGS, or we can call it as the voltage across here is Vin. Both are same, right? So now you tell me what is the voltage Vin. As per the voltage division rule, Vin equal to total voltage Vi into that particular resistance. What is the resistance we have? Ri divided by sum of the resistance RSI as well as Ri. Okay. So Ri plus RSI. That you have to substitute in this equation. Clear? So the third equation you have to substitute in the place of V in. So you will get V naught equal to minus Gm into Vi Ri by Rsi plus Ri into R naught parallel to Rd parallel to Ri. Now our required parameter is voltage gain AV, right, which is V naught by Vi. Here we have V naught, here we have Vi. So this Vi, if I am bringing this side, left hand side, I will get AV, right? So up to here, the analysis of common source amplifier with the bypassed RS is over. Okay. So in this, you have to think one thing. Suppose in the problem, if they have not given the RSA, right? If the RSA is not given in the problem means you have to take it as 0, right? So the AV will become when RSA is 0, which is equivalent to, if it is 0 means 0 plus Ri equal to Ri. So Ri will be cancelled. So you will be having minus Gm into R naught parallel to Rd parallel to RL. Right. So this is the output, that is a gain formula you are getting, right? If RSA is 0. Suppose in the same problem, RL is not given means, see, if the RL is not given, that means without load. Without load means the formula will become minus Gm into R naught parallel to Rd. Right? So like that you have to take. Okay. So with this, I'm going to wind up the session of this. And one more thing you have to know why this minus means. See, this is a only amplifier will produce a 180-degree phase shift. So we have three configuration: common source, common gate, and common drain, right? But out of these configuration, only the common source amplifier will produces the 180-degree phase shift. That means if the input signal is like this is your input signal, your output signal will become, that means the output signal will be 180-degree out of phase. That's why we are having minus, right? For common drain as well as common gate, we are not having this kind of minus in the gain equation. So thank you all. I will stop here.